Then here the copper is formed, right? Like this is
I'm
Cu.
sharing, sorry, I'm sharing the screen, but you don't have to worry about it. Right? Okay, so you have copper there and you have the impure copper. Okay, sure thing.
Yeah, this is correct,
Um, is that one you want to ask, the pure and the impure, or is it something else that you want to
right? No,
ask?
I want to ask, right, like why do they only use Cu as the file? Can't they use anything that is above copper?
Of course, let's talk about it. Now, that is a good question. Now, let's just check first whether the impure and the pure one is correct. How do we check? They are more than one ways. And this is how I will check, because I'm a person who don't memorize one. I try to simply understand, but there's nothing wrong with you to memorizing, right? This is how I will check. I know that this is electron flow like that. Okay.
Yeah.
Now, if this is impure, then what I want is Cu to become Cu2 plus.
Yeah.
I'm sorry, that's a problem. If that is what I want, then the reaction looks like this, correct?
Yeah. Correct.
Does this mean that the electron will go out? This is how we see the electron going out. Does that mean that?
Yes. No.
And you think, well, I do the other one first because all have to make sense. Copper is formed, so in this case,
The other one is
Cu2
just
plus
Cu2 plus to Cu.
plus 2 electron becomes Cu, which means it needs electron to go in, no? Right? It needs a supply of electron. Correct, and this is both correct. You see the electron flow for a while. Obviously, electron going in will give you the thing needed, right here, right? And this one is Cu becoming Cu2 plus and 2 electron. Just for your information, the electron does go up, not into the solution.
Yeah.
He will go up to the wire because cutting short, that's the easiest way to travel for electron. Electron cannot travel in water one, just to say that. And then the Cu2 plus will go the other way. Because Cu2 plus cannot travel on wire. It's a totally different scenario. Cu2 plus will prefer to go into the aqueous side of things, right? And therefore, this is totally the right reaction if I want the electron to flow out. So also it makes sense. So both sides make sense, right? That's how I check whether your impure and pure copper is correct. You can memorize if you want to. There are many ways to do it. If you want to know how, or if you don't, your teacher don't tell you, then just tell me. But it doesn't seem that you have that problem. So that's clear. Now, to answer your question, now, the CuSO4 here is, use a different color, Cu2 plus and SO4 2 minus in an aqueous system, right? Now, the red one is the original thing there, and the blue one is the supply, right? Now, look at this for a while. Initially, the blue one will not go in. Initially, the red one will go in. This is important in the initial stage of the reaction because not enough blue is going in yet. The blue cannot reach this side very quickly. One cannot. It takes some time. Therefore, the red is needed. Now, you propose to change the red to something else, correct or not? You propose to change the red to, I'll give you two options. I can use AgSO4, okay? For example, that's below copper. Or I'll use, I don't know, for example, Fe, which is slightly above. Right?
Above. No, you're right. It's below.
If it is above,
if it's above,
nothing will happen.
Be the one that is. Yeah.
If it is above, then in that case, H plus will win.
If we what?
Fe, H plus will win. The guy above H plus never win.
Oh wait, no, no. Okay, so I thought that it was above, right? Because that, like, but why would H plus win? Won't Cu2 plus win?
This is no. If there is no Cu, if there's no Cu2 plus, remember the Cu2 plus from the blue side does not come very quickly. I'm talking about the initial stage. The initial stage is still important to think. Your teacher probably don't talk about this, but the initial stage is where the Cu2 plus only start to enter the liquid, the water, and haven't got time to travel here. So there must be something in the water itself to kickstart the process. If there is nothing to kickstart the process itself will never happen.
Wait, so if they don't use Cu SO4, nothing will happen.
Well, they can use AgSO4 lah. To be fair lah, they can use Ag2SO4. And who say they cannot use H2SO4? They can.
But if they
can use.
if they use AgSO4, right, then
yes,
wouldn't
will form.
Silver be formed.
Therefore, this is no longer pure copper, which is the problem. No? We want pure, ma? Ag will cause it to be not pure, a big problem. There are many other problems, but just put it this way, that's the biggest problem. No? How can you get pure copper like that? That's the whole purpose. Ma? Okay? So Ag plus is not a good idea, not because it doesn't work, but because you want pure copper. Now, if you put anything else above, I mean, to be fair, there isn't much other thing above, right? I mean, it's only Ag and Cu, right? You don't even consider gold. Gold is almost never a consideration because the gold already have trouble becoming Au2 plus, right? So the gold is not a consideration, right? Now, anything above the Fe3 plus, you will be replaced with H plus. H plus will win. No? This is clear first or not? This is what you learn. The H plus will win. Anything, if you put anything above Cu, PB, Fe, whatever, the H plus will win. Correct. So H plus will always win because that's the next step above, man. And nobody else will win against H plus.
After a while, right? Shouldn't the Cu2 plus come out from the?
After a while. So is that a problem or not?
So is that a problem? It's slower.
It is slower to code, but now let me give you the practical thing. So because I understand the practical side of things, your syllabus just cover the theoretical side. So this is just for your information. I'm not trying to confuse you. Are you okay, Jonty? I'm just telling you something outside the syllabus. Okay? And yeah. So the H plus will cause bubble, correct or not? Because it will form. Yeah. So the bubble itself will cause a lot of problem practically. This one is something that you don't study and you don't have to know, just for you to know. The bubble will first cause the Cu coating, because I'm coating Cu with Cu, to be imperfect, to be not how do I say it? To not be smooth. Let me just put it that way. It won't be a smooth thing compared to if you never transition from H2 to Cu. If you just go from Cu to Cu, it will be incredibly smooth, which is what we want out of a pure copper slab. If you bubble it first, that's the first thing, that it will not be smooth. And if you don't control the bubble too much, because it is difficult to predict when the Cu2 plus will come in here, then the bubble will actually sometimes cut off the whole connection. Because bubble is an insulator. Just think of it as a foam. No? Bubble too much, the whole thing stops, which is very, very annoying and very destructive. Now that's the practical side of things. Am I confusing you, or am I? Are you okay?
Yeah, okay.
Right. So the scenario theoretically works if you never consider the practical problems. So theoretically, you're right, it works though. And your syllabus will probably stop at the theoretical side.
But they won't ask me kind of question.
Even if they ask, they will give you only maybe 1 or 2 marks. That's the latest part of the question, and it is considered the what do we call it? The induction question. No? Like you have to think outside the box kind of question, and you have to rely on some sort of external knowledge. It's a very rare question if they ask, so I wouldn't be worried about it at all. I wouldn't be. They tend to not do that. They tend to not. They don't test that way these days. They don't test your other knowledge these days. They don't.
Okay, so for my Friday test, right, they are testing fuel cell, but I don't understand how fuel cell works. So I also want to answer that.
Yep, fuel cell should be the hardest battery to understand, and so I guess we can try to understand. It is the hardest battery. If you have a picture, better. If you have a picture from your node, that means at least you can, if you can draw it properly. If you cannot, go ahead.
I remember it's like that. I don't remember exactly, but
I mean, you can draw the most basic one first. Give it a try. Okay.
The sea, right? No, got water. H2O.
Eh,
The sea.
okay. Concept first, yeah, John. Yeah, concept first. So the chapter actually talks about electrolysis and cell, right? And they are the reverse of each other. Am I making any sense?
No, I don't understand what you mean. What?
Okay. You must understand this. This is not optional, yeah? So listen to me first. Electrolysis requires electricity in
Correct.
order to make chemical reaction that wasn't possible. So to simplify, my input is electrical energy. I cannot do it without electricity, right? In the form of battery. So my input is electrical energy and my output is, so to speak, chemical energy. How do I know that? Because the reaction that is happening usually are the reactions that are not supposed to happen. That means the reaction which is not supposed to happen this direction, it is supposed to happen in the other direction. So I'm forcing it to happen. Electrical energy in, chemical energy out. Am I making any sense for electrolysis?
Yeah.
Cell is the total opposite. Let me put it this way. Power bank. Power bank, you charge the power bank so the power bank can charge your handphone. Simple, right? Now you tell me, when the power bank is charging, not charging other people, when the power bank is charging, is that electrolysis or is that cell? Am I making any sense?
When the power is charging.
Power bank. You have a power bank, right?
Yeah, I have a power bank and it's charging.
My power bank is gone, right? Oh, finished already. Tomorrow I need it. I charge it, I plug it into the wall, right? You don't know anything about the chemistry of battery. What is that?
That's electrolysis.
Very good, because electrolysis needs electricity. Simple. What happens inside the power bank? You never learn power bank in the syllabus. The syllabus is old-fashioned, right? But if you learn what is happening inside power bank, it will look kind of similar to electrolysis. Some reaction is happening inside. Oh yes. In the end, it is still chemical reaction inside. That one I guarantee. It's just that it doesn't bubble. It doesn't get very hot. It just get hot. Okay, power bank charging hot, man.
Yeah.
Most chemical reaction do become hot when they happen. Only some become cold. So there is a chemical reaction happening inside, which if performed incorrectly will bubble. When it bubbles, the power bank blows and then after a while explodes. I mean, you have seen videos of power bank, lithium ion batteries bloating.
That's how like last time the phones explode.
A slightly different one. In the inside, the power bank short circuit. When it's short circuit, the reverse reaction happens. So it's the other way. That means when it becomes a battery. Usually most power bank don't fail when it is charging. It is failing when it is discharging, a very fancy word, when it becomes a battery. Now, go back to our syllabus first. So when it is charging, it is electrolysis inside, just no bubble. When it is charging your phone, does it make sense if it is electrolysis? Think carefully.
When it's charging my phone.
Yeah. So when it is being charged, but when it's finally being used by you, charging your phone, which is gone, your phone is gone, plugging your power bank. Does it make sense for the power bank to be doing electrolysis if he is supposed to charge your phone? Think carefully.
I think so.
Are you eating? By the way, you should be eating. You haven't been eating. Are you eating?
Yeah, I'm eating.
Good. No, it doesn't make sense, John P. But why? Very simple. Electrolysis require electricity, right?
Yeah,
that's what we understand.
The electricity is being provided by the power bank one.
No. That's your phone battery acting for electrolysis, but the power bank is not acting like electrolysis because the power bank is supposed to provide electricity, not ask for electricity. The power bank is not electrolyzing at that point. If it is electrolyzing, he will demand electricity. How does that make sense if he is supposed to charge your phone? Am I making any sense?
No, okay. I don't understand.
Okay. I'm sorry, sir. You understand or don't? Sorry.
I don't understand. Don't understand.
Okay, one more time. I'm going to draw. Okay. Power bank here, right? Yeah, let's say you have a big power bank, either 20,000 one. Sometimes it's a fake one from Shopee. So buy carefully lah. Now, this one, plug-in. Plug-in, ding dong. So electricity goes in, right? Electricity goes in, keeping it very simple. This is electrolysis happening, which is still true up to this point. Now I use the power bank, which is the same thing. I use the power bank. So I use the power bank and I am plugging it into my phone. There's my phone, right? Now the electricity is supposed to flow like that. That's what you expect. What? That's called charging. Inside your phone, there is a smaller battery compared to the power bank. That's why your power bank can charge maybe your phone 4 or 5 times, right? So this is a bigger battery inside the power bank, a smaller battery inside the phone. And inside your phone, your battery is performing electrolysis.
Inside the
totally
phone,
correct.
The battery is
performing electrolysis.
Oh, but
makes
for
sense,
the
right?
power bank is
Yeah, it is not. How can that be? How can that be? That means your power bank can do reverse electrolysis. Whatever that means, electricity is now provided, not demanded. In your syllabus, even though I say your syllabus is old-fashioned, but in your syllabus, that is known as being a cell, which is to say, being a battery. When you buy a battery, you expect the battery to give electricity, and additional bonus is sometimes the battery can be charged and then provide again. But initially, when people construct battery, they just think of battery as providing electricity, no rechargeable battery. So your power bank can both electrolysis and can also cell. Both. Not at the same time because it is kind of too hot, very bit dangerous to do both. Okay? A bit dangerous to do both. Are we clear at the concept level first?
I think so.
Then my question to you is your fuel cell. It's called a cell. That means it's a cell. Does it make sense for a fuel cell to demand battery? That means to demand electricity. That's what it means.
No, it does. The fuel cell
It does not. It does not demand battery, electricity battery at all because it is supposed to provide electricity. So very important concept. The drawing here is not supposed to be a battery. There is not supposed to be a battery anywhere in a cell because the cell is the battery. This is not philosophical. This is the concept. Makes sense or not?
Okay.
Now, what do you put here? Then usually in the drawing, it's not a battery, but you still need to put something on. So what do you put there?
I don't know.
Okay, usually for simplicity's sake, they put a voltmeter. Below. Think carefully. A voltmeter is a battery or not?
No.
A voltmeter actually requires volt. That means he requires battery. That means he is not a battery. That's the point. That's the point. It is just to measure the voltage, which is to say, that means he is measuring a battery. There you go. That's your battery. Your chemistry syllabus is learning the inside of a battery. In this case, a fuel cell. That's the battery. This is the battery. A cell is the battery. Clear first? Okay. To be perfectly clear, you can put other things. For example, you can put your phone into the fuel cell. That's okay because a fuel cell also demands electricity. As in your battery, your handphone demands electricity. So that makes sense. You can put voltmeter, you can put your phone, you can put your car. Just don't put a battery there. Clear, yeah? Now, your drawing is also not perfect in many other ways, but it is because fuel cell is, I think, actually kind of complicated to understand. So the drawing is not easy. Are you sure you want to relearn the drawing, or maybe you can just, take a picture from your note first?
I don't have
because
it
is in school.
Yeah.
So your teacher just reached fuel cell. Is that why you're asking things?
No, my like we did this long time ago, but I was revising, then I didn't understand.
Then let me take the time to strengthen your concept lah. Now go to page now.
I have a video for. I mean, I can just put in an image.
No. Yes, you can put it there. You can put a link there. I'll extract the. That is a much better drawing. But now, would you please go to page 9? Would you please go to page 9? So that's the before your drawing. Go to page 9. Now, could you draw me a normal cell, not a fuel cell? Fuel cell is, more advanced lah. Can you draw me a normal cell?
Like electrolytic cell.
Electrolytic cell is not a battery, as in it's not a cell. Electrolytic cell means it is electrolysis. Now, I don't want you to draw electrolysis. I want you to draw battery.
Huh?
Again, just now what you're drawing is something that requires electricity. I want you to draw something that gives electricity. That's the whole point of learning cell. Just now you draw a battery, that means it's already wrong. Having said that, the drawing for a basic battery, a basic cell, and the drawing for a basic electrolysis looks very similar. That's why people cannot fool. It looks extremely similar. It is totally different in function. You gotta understand that first. Okay, that looks like a normal battery. Let's see how you complete. Yeah, nice. Well, what happened to the electrolyte? There's also electrolyte there.
You can put anything, right? This one can just put anything, right?
You can. I guess you can say that. Sure. H2SO4. Sure. ICL. Sure thing. Right now, so that there is no short circuit, I go back to physics for a while. If you do this, it will be a short circuit, so not very good for a battery. Would you please put something else there? Just not a battery. All right. Okay. So you're correct. Look, this is a basic cell, a basic battery. Look. Now I want to know whether you understand how this works. Okay. How do I understand it? It's very simple. I'm going to ask you something very simple. Where does the electron flow? The electron can only flow either like this or like that. You tell me, how does the electron flow? This is how I test your understanding.
How does the electron flow?
Yeah, only in one direction. Either this or that.
Yeah.
Now, whichever you choose, you tell me why you think like that.
What's more reactive, less reactive? What?
So you're right. One is more reactive, one is reactive. So what does that mean? Then what happens?
So like the electrons will flow that way lah.
Why?
I actually don't know.
Let me encourage you that you are correct, though. You're correct, though. Now, there always be two reactions, right? So very similar to electrolysis, but again, totally different purpose. So there are always two half reaction. Which one is the easier one? Can you write for me the two half reaction? If you can, then I'm happy already.
The two half reaction.
Yeah, there's always two half reaction in both cell, battery, this one, and electrolysis.
Yeah, okay, so this one is H plus, 2H plus.
You're correct. Sure.
I forget.
Oh, goodness me, right.
No,
this will be correct if this is this will be correct if this is a no, actually no. So no. Okay. So, yeah, it's not correct. Okay, so it's not correct. So this one is actually much easier to understand. The basic battery is supposedly much easier to understand than electrolysis or the fuel cell. Fuel cell is the slightly more advanced battery, right? Slightly more advanced. Now, you already say the correct thing. Zinc is more reactive than copper. Your thinking should be like this. Therefore, copper don't react. Zinc will react. You didn't follow through. Zinc is supposed to react. Copper is not supposed. So zinc is one of the half reaction. Does that make sense?
Oh, that makes sense.
So what happens to zinc? That's all you need to think, and it's quite kind of easy to figure out what happens to zinc.
Zinc.
Zinc will become.
Yeah, it will just become.
Because there's no other thing to become, right? Zinc will just become 2 plus, right? Now look at this reaction. I will usually think of this first, then that. There's nothing wrong with your method, okay? Your memorizing is correct here. It's just that it's wrong here, right? So logic and memorization go hand in hand to help you, right? So what I told you makes sense, and then you're more confident that this is happening. Later we'll see why this is not happening. Yeah, later we'll see why. Right now for this one, this is happening because there's no other way for zinc to become. Zinc will just become zinc 2 plus, and the electron. And the same thing with electrolysis. Everything is very similar. The zinc 2 plus will prefer to go into the solution because he cannot go into the wire. And the electron will prefer to go into the wire because the electron cannot go into the solution. Furthermore, positive should go different way from negative. That is just because they are opposing each other. So it works out well for both. And therefore, your electron flow is correct. No? Therefore, once the electron flow, your other reaction is proven correct because the other reaction should be a reaction that accepts the electron. There you go. I think your reaction here makes sense simply because of that. Okay, so it's not going to be Cl minus accepting the electron, like no way. It's not going to be OH minus, which is available accepting the electron, also no way. So your reaction must be correct, look, and therefore there will be bubble, and therefore this is a bad battery.
So if let's say I replace let's say I replace zinc with potassium. No, let's say I replace zinc with sodium, right?
Yeah, which is a bad idea, but let's pretend that it can happen. Why is it a bad idea though?
Because it will explode.
Correct, but let's pretend it does not. So what happens?
Pretend it does not. Okay. Yeah, I replace zinc with sodium. Then then the right side. You put something that is above copper, but below sodium, like magnesium.
Okay, let's pretend. Let's pretend all that. So let's do this. So this is sodium, and then this is magnesium.
Yeah,
so
then right. Will magnesium be the one that react and not?
Of course not, because sodium is more reactive. Of course not. Sodium will react, not magnesium.
On the right, because on the right is
magnesium.
Yeah, but on the right is H plus. Wait, so the electrode will not react unless it is more reactive.
Okay, let me put it in the simplest way. For a simple battery, this is a simple battery, simple cell, not your fuel cell. In a simple cell, there will always be two metals, and there will always be two different metals. There won't be a case where it's Cu and Cu. Like electrolysis, that can happen. In a battery, that will not happen. Simple battery, two different metals. If it is two different metal, then one of them will be more reactive, one of them will be less, because it's not the same metal. Make sense?
Makes sense.
So therefore, the more reactive metal will react, and the less reactive metal will just stay there. Simple. One metal will be consumed, one metal will not. That will always be the case for a simple battery like this.
Okay.
Sometimes I suspect that it is so simple that your teacher sometimes browse through the explanation. It feels like that.
I was absent for a simple cell, so I think.
Right. Okay, and therefore simple cell like that. That is the basic thinking of a simple cell. One metal will react, one metal will not. That's the half reaction. I just have to figure out the other half, which is usually very easy to figure out. It is so simple. Can you accept that for the case of sodium and magnesium?
Yeah, I can accept.
Now, to be very clear, so that we are not in doubt, if I reverse the Zn and Cu, obviously it will still be a battery, but the flow and everything else will just take place at a different spot, right? Does that make sense? Right? There's nothing wrong with doing this, right? Because in electrolysis, if you swap the electrode but don't swap the battery, sometimes totally different thing happen. Correct or not?
Mm.
But in a cell, because there's no battery, he becomes the battery. If I just swap the electrode, same thing will still happen, just in a different spot. So it becomes also simple to figure out. Clear, yeah? Can yeah? No problem.
Yeah.
Do you need convincing that this reaction is not happening? Do you need any convincing?
No.
All right.
I understand.
So this is a simple battery law. Simple battery law. So now we are hopefully ready to talk about the fuel cell. So let's go to page 11.
Where?
Look at this. Look at this. What is that? Why is he
Where?
putting load? What is this, man?
I have no clue.
You have no idea?
Yeah.
The point is, it is not a battery. The point is not a battery, but something that needs battery.
Wait, so load don't mean anything.
Load means something in physics. I'm sorry, they're using physics in chemistry, so sometimes it becomes confusing. But when you say load in physics, they just mean that something that require battery or electricity. Meaning, for example, your aircon is a load. It requires electricity to run. Your fan is a load. Your computer is a load. Your phone is a load. You know, all those stuff. It's a load. In physics, you might have learned that anything that requires electricity, like your washing machine, your, I don't know, your air fryer, everything is like a resistance law, because a resistance, well, so to speak, eats up electricity, so to speak. The point is that this is a resistance law, a load, something that requires electricity. Does that make sense?
Yeah.
It can also be a voltmeter. Fine also. It doesn't have to be a voltmeter, is what I'm trying to say. So where is the battery? If this thing requires battery, so where is the battery?
Battery.
Where is it?
Is it not the battery?
One more time. A load is not a battery. You're still not
the
switching.
battery is the alkali fuel. I thought you were talking about the fuel cell. It is the battery is the fuel cell.
Correct. So the alkali fuel cell is not this. The alkali is the whole thing except the load. If that makes sense. I think the positioning of the word alkali fuel cell is a little bit confusing because it's everything besides the load, right? Something like that, right? So as you may imagine, it makes a lot of sense for a battery to give electron. So like that, electron. So there's an electron flow. Okay. Now, time to understand what is this hydrogen, this is oxygen, whatever, and what is happening in between. But let's try to understand the hydrogen first, the oxygen, and the anode cathode. Now, let me ask you, what is the anode and cathode made of? That is something that doesn't exist in your drawing. A little bit not okay. So what is it made of?
If I'm not wrong, it's inert, so it's like carbon, right? No.
You're correct. No, you're absolutely correct. You're correct. So here the anode and cathode will be inert, which means there are only two options. Practically only two options. One. So your graphite or your platinum also totally okay. Because whenever they put carbon and platinum, graphite in your electrolysis side, it means that you don't have to worry about them. Like best law. Same thing as happening here. If I put it here, it is going to be inert. It is just going to conduct. It's not going to react. So happy for me. Happy for me until I realize, hey, my simple battery, usually one guy react. Hey, how come now I have nothing reacting? So a little bit confusing. Just a little bit confusing. Correct or not? Hey, my basic thinking doesn't work here in the fuel cell.
Repeat that. I don't think.
One more time. Here's the drawing of the basic fuel cell. I tell you, in a basic fuel cell, in a basic battery, there will be two different metals. One react, one don't. So one person will always react in a basic battery, which you need to know because they ask more of the basic battery than the fuel cell. The fuel cell is not a very common question, right? Are you okay? Your basic thinking does not work here. Wait a minute. One of them is supposed to react. They are not reacting, both of them. Okay, that thought a bit confusing for me. Fair enough, no? Right? Can I say that? Is it okay for me to say that? You sure you're okay, Jonty? You look distracted today.
It's just a bit
One more time, one more time. When we draw a basic cell or battery, the first thing that we do is to draw two different metal. You just randomly give me two different metal, not the normal copper and zinc.
What do you mean two different metals, not copper anything? Like anything?
Or anything. Anything will work as a battery, I guarantee. I guarantee one. And you're still drawing a battery for a battery. It's your old thinking still not, still not working. It's not working. You also are not supposed to shortcut it. You cannot shortcut a battery. It's sometimes very dangerous. This is what causes the power bank to explode. If you shortcut it, it explodes.
What do you mean shortcut?
You connect basically the positive for the negative node. Like you have a normal battery like the small one, the AAA and AA. If you connect the positive and the negative, it won't explode. Don't worry. If you connect it means through a wire. They are separate for a reason. They are not supposed to be connected directly. But if you try to connect them, they won't explode because very low voltage. You try to connect the positive and negative side. The power bank. If you try to short circuit your power bank, one of them is positive, one is negative. You can, inside the USB, there's a positive, negative. If you try to connect them and their protection fail, that means your protection cannot damage for a while, the power bank will explode very, very soon. You are not supposed to shortcut a battery. I'm telling you this not for syllabus, not for exam. I'm telling you this for your practical life. Don't short circuit a battery. Because
but the one I drew is short circuit.
It is short circuit because one of them is the positive and one of the negative side of the battery. And by putting a wire through the positive and negative, you are short circuiting the battery, which is dangerous for a power bank. Which is why they build a lot of protection into the power bank. So don't short circuit it, put a voltmeter, which is therefore not a short circuit, but a load, or put a load, put a resistance.
What the normal, they put load, okay.
Yeah, volt or resistance load, don't short circuit it. For your sake, I'm telling you for your sake, not for sake, right? Clear, yeah? So do change for me.
You already did it.
No, you have to read. Okay, good. So then I just tell you that one of these is the positive side and negative side, but I never tell you which one is positive and negative. I'm just pretending.
It doesn't matter, right?
It matters. It matters because the way you put in the case, the zinc and the Cu.
Yeah,
if you put the zinc on the left,
so I can just.
You have to put first. No, you have to put first. Yeah, you should put first and then adjust the positive, negative. Not the other way around.
I'm not wrong, right? The positive one should be, like, let's say the electron flow is this way.
Okay, let's say yeah.
The positive is right. This end, right?
Let's test. I'll test your knowledge if you don't want to memorize. I'm taking that you don't want to memorize. So let's test. Okay, question mark. Now put in your metal first.
I can use zinc and copper again, or you want something else?
Something else. So that you know it's not just zinc and copper. So that you learn.
I can use medium. Okay, I'll put MgAl. That's okay? No.
Mg and what's an AP? I'm sorry. Oh, aluminium. Yeah, all right. Okay. All right. So tell me who reacts. Tell me first who reacts.
Oh, Mg reacts. No, no.
Mg reacts. Yeah, okay, that makes sense. No, Mg reacts because aluminium is slightly below Mg. Remember, the reactivity series is group 1, group 2, group 3, easy to understand, right? So for our sake, we just learn, we just write down first Mg. Mg becomes Mg2 plus and electron, right? And what will happen to the aluminium?
Aluminium
what happened to the aluminium?
nothing.
Oh, you're supposed to answer nothing. Yeah, okay. Nothing, nothing. Something else will happen depending on what is inside the electrolyte. Something else will happen. No? And therefore, your electron flow seems correct. No? Correct? Because something is supposed to go out of the Mg, which is the electron, and the Mg2 plus is supposed to go into the electrolyte. So it makes sense. Totally makes sense. And yeah. Now, the question is, does that mean that this is the positive side of the battery and the negative side of the battery? Is this your question? Is your question, is this the positive side of the battery and the negative side of the battery?
Or I'm pretty sure I'm correct, but I'm not.
Is that your question? Let me just confirm that. Is that your question or is it something else? This positive, negative means what to you?
Because like in physics we haven't learned this yet, so.
So what do you mean that you haven't learned? So tell me what
like we I don't think we've learned like, because on the diagram we just draw the voltmeter, we don't put positive, negative, like, you know. So
Okay.
like,
you learn physics, right?
Yeah,
you learn physics, right?
So I
okay.
also not sure
I'll refer to your physics, okay? I'll refer to your physics. So now physics a little bit, I switch mind for a while. Huh? Now in physics, we learn battery. I'm drawing the battery like that. Okay, just to make it clear. This is called the positive end of the battery and this is called the negative end of the battery. Okay, so far so good? Then we put the battery connected with something else. All right, so let's say your washing machine. There you go, this is your washing machine. For some reason, your battery can run a washing machine. So cool, right? Now, how does the electron flow through the washing machine?
Electron is negative, positive, down.
Correct. So electron like that, correct? Electron like that.
Yeah, but
am I
correct?
You
use conventional current.
Correct, which is not the real current. Conventional doesn't mean the real current. So for learning purposes, it's better to think about the electron flow, because electron is what matter actually in physics and in chemistry, even better in chemistry. There is no conventional current in chemistry, even though obviously there is, but don't touch on that. There's a quirk in history where back then people think that current is positive, not negative. Back then. They don't intentionally do that quirk. It's not an intentional sabotage to make us confused. No.
Yeah, it's because they thought it was positive charges moving.
Correct, which is they have to make an assumption. They have to make an assumption before we know things, and then end up 50, 100 years pass before we know the most correct thing. Then at that point, it's too late to change that. Okay, now you think about this one. Now the battery is here, right? The battery is here and the washing machine is here. Now, therefore, in your in your normal cell drawing, this is the washing machine. Am I correct? That's the load. It's load there, here and there. Correct or not?
Yeah, but what charge is the washing machine?
What do you mean by what charge is the washing machine?
And like, because like the washing machine.
Good news for you. The old technology washing machine, even aircon, even fan, they don't care about positive negative. They can accept either way. Doesn't matter. So we don't have to worry. Right? My question is more like this. Look at the flow from the physics side. The flow is from negative side of the battery through the washing machine to the positive side. You know this, audio?
Yes.
Okay. So look at the electron flow here. So electron flow here like that. Electron flow like that, which is going to be correct because again the Mg is the one reacting. You notice that the one that starts here is actually called the negative side of the battery.
Yeah, but
and this is actually called the positive side of the battery.
Wait, what?
Compare the one time. I'm asking you to compare the chemistry drawing and the physics drawing. Okay, I'm asking you to do that. We are joining the both.
But is I thought negative goes to positive, so isn't this positive?
No. First of all, a washing machine don't have a positive and negative side. This one, just believe me for a while. A washing machine don't have a positive and negative. A battery has a positive and negative.
The voltmeter also don't have.
A voltmeter also doesn't have, meaning to say if you put it wrongly, if there is such a way to do it wrongly, the arrow and the needle will just move the other way one.
Yeah.
Either left or right, but it will move lah. It will move. It will not explode. It will not. Okay. Of course, your laptop cannot handle that. Of course, your phone cannot handle that. But even your phone, they develop USB-C. You plug here, you plug there, doesn't matter. Just consider normal technology, the
So
guy you're plugging in
whichever
doesn't
end
matter
is
one.
closer to the negative end is negative.
No, I'm thinking about the electron flow. The electron flow like this, and therefore we know that this is the negative end of the battery and the positive end, because the electron flows from the negative side of the battery to the positive side. That's physics. That's what I'm thinking. I never think about the washing machine. I look at this. Oh, the electron flow has been established to flow from like this because of the reaction. Yeah, then this must be the negative end of the battery, and this must be the positive end of the battery. Must be because physics.
Also, I don't care about the voltmeter law.
Yeah, the voltmeter has no end one. The battery has end. The voltmeter have no end. Physics wise, physics. The battery has end. I'm interested in the battery end of things.
Okay, I understand.
Okay, so therefore I call this the negative part of the battery of the cell, and this I call positive, just based on how the electrons flow. Simple.
Okay, yeah. Makes sense.
I hope this makes sense. I hope this helps you in exam in a way that it reduces your memorization. Nothing wrong with memorizing stuff. There's nothing wrong with that. Okay. I think the schedule for chemistry O level is not as crazy as last time. Last time, the schedule for chemistry O level paper 2, right, is directly after AMAT paper 2. Which is just crazy, just crazy. Back then,
Why?
I think
AMAT got 2 papers, only 1.
Two. Now you know. Paper 1, paper 2. The worst paper in history, the longest and the most time constrained one. AMAT. And then they flush it morning AMAT, chemistry afternoon. Just crazy back then. People just die left and right. Back then, no, I think until 3 years ago, 2 years ago, I think 2 years ago is like that. Then last year, the schedule becomes friendly. Then I think you have a better chance of memorizing, because imagine you have to do AMAT on the morning and then chemistry. Then, well, first of all, which one do you study? Secondly, how do you memorize chemistry and still study AMAT? Like most people just kaboom, most people. Maybe you won't, but most people just boom.
Yeah, but if I understand, of course it's better.
Correct. Understanding is always better, but some people don't think like that. Some people think, why bother to understand? Just memorize easier. Wait until you do the exam, then boom.
Okay.
Good for you that you want to understand it. Good for you. Really good for you. Right? Even though you don't want to take science. So why do you bother to take science? Why?
Huh?
You say you don't want to continue with science?
Yeah.
Okay, why bother understanding science then?
To do well in OSA.
Fair enough. Right. And it will carry you beyond exam.
If I understand, then like it's always possible. Like I'm not closing the door to science, just that I don't.
You have a preference.
Yeah. So if in the future I end up in that field, then it will be better for me to understand.
Correct. I like those kind of answer better than doing well exam, although obviously you will do well exam just because of that. If you want to understand, you will do well exam, but you will also carry it beyond exam. Good for you. Good for you. That means what you're learning is not a total waste of exam. Okay, now back to the cell. Now looks like we did cover grounds that you haven't covered. Good for you. Right? Are we ready for the fuel cell, which is more advanced, or do we still have to talk about basic cell? Feel free to.
Sorry,
do we still have to talk about basic cell? Feel free to talk about basic cell until you fully understand.
I understand now, but I like because I did not know I had this misconception, so that like I might have other misconceptions. If I encounter them, I'll ask you.
Sure thing. But the good thing about basic cell is very simple. Perhaps maybe there is no more. If you discover it in exam, as in working exam question, then we'll talk about it. Right? I don't think you will be worse off during O level. Probably you will be better.
How for what?
Okay, now because you still have a lot of time. Once you understand the basic concept in basic cell, which they ask more often than fuel cell, right? Then in exam questions, you'll be able to handle them better, more properly.
Oh.
Then you'll grow. I mean, after basic understanding, the only way to grow is to exam level question. Okay? So you'll be fine. Right. So now alkali fuel cell, something that they teach you, something that doesn't appear often in exam. It does happen from time to time. And something which is more modern, like the fuel cell. Actually, no. Actually, fuel cell is a technology that, and why are we even studying this?
The fuel cell the fuel cell don't exist anymore.
Huh?
The fuel cell don't exist anymore.
Our surprise, the basic battery still exists in a very similar form to when it was kind of invented like around 200 years ago, almost 200 years ago.
Yeah.
The technology almost never changed. That's the material change. The concept is still the same. The fuel cell, which is supposed to be the future, 30 years ago, 40 years ago, a fuel cell is the future, not happening at all. This is not the future. Fuel cell is kind of a dead end.
Wait, why?
Because for fuel cell to work, the oxygen is not the problem. We have oxygen everywhere, correct? Quite easy to get oxygen. The hydrogen is the problem. For fuel cell to work, you need both hydrogen and oxygen. The dream is that you have no pollution. Fuel cell have no pollution. Because hydrogen and oxygen, when you react them here, it will produce electricity, good for us, and will produce water vapor, which is totally non-pollution. That's the promise. That's not happening at all. Totally not. That's the background of fuel cell and why you study fuel cell. Because back then it is supposed to be the great thing. It's not. I'm pretty sure it's not going to happen. So it's a dead end to me. Because producing hydrogen is a big problem. You don't have hydrogen flying around in space, man. The production of hydrogen is kind of a big problem, The bigger problem is storage of hydrogen.
But isn't hydrogen one of the most abundant elements?
In the universe, unfortunately, not in the form of H2. Unfortunately, you need H2 here in the form of H2O, in the form of H2SO4, it's not in the form of hydrogen. You cannot just put in water in a fuel cell. That's not how fuel cell works. Fuel cell produce water. You cannot put in water. I mean, think about it for a while. Does it make sense for people to say, okay, I need hydrogen for my fuel cell, right? I need oxygen also. Okay, oxygen is the easier part, fair enough. You just liquefy, you get oxygen, right? But to produce hydrogen, first thing first, I electrolyze water.
Yeah, so but water take electricity. So it's like
which is then what's the point? What is the point? There is no point. If you want to produce hydrogen with electricity, then they say let's produce hydrogen chemically to other reaction. That's the problem. There is the problem. Then the other problem is storing hydrogen in your car. You're supposed to store this in your car. How am I supposed to store hydrogen and oxygen in my car? Very cold temperature and very high pressure. That's a problem. That is a problem. Thirdly, hydrogen leaks. Fourth problem. Hydrogen turns out to cause a lot of global warming. Fifth problem. Too many problems. Really. The future is not this. So personally, I find learning fuel cell to be a curiosity only. It's not going to be very useful. It's just a curiosity. That's me thinking outside exam. Inside exam, we learn it for exam. Fine, that's fine. I'm telling you this because you are interested in understanding. Okay, if it is too much, just stop me. Right? Okay, so having with all that background, I tell you that the basic cell is more important because that's still your battery. Okay, now the fuel cell we'll talk about it. Right? So I start the fuel cell by talking about the electron flow, which is what you expect from a cell, right? You expect a battery to give electricity, so no problem with that. And the anode and cathode, which already gives you a something slightly confusing because the anode and cathode both are not reacting, both are inert. Okay, so far so good. So none of the anode and cathode are reacting, but there must be still a reaction. No? By that, counterintuitively, hydrogen and oxygen will both be doing the reaction. So hydrogen will be doing a reaction, half reaction, right? Oxygen will be doing the other half, and the end result is water for some reason coming out from this side, not from this side. So to keep it very simple, when I combine the two halves, it will be hydrogen plus oxygen becoming water. And then I balance it out. This is 2 and this is 2. There you go. That's the total reaction of fuel cell, which looks a lot like I just burn hydrogen in air, which contains oxygen, and produce water vapor.
Why burn?
Because for hydrogen to react with oxygen, or for anything to react with oxygen, that's burning. Burning is a reaction with oxygen. No oxygen, no burning. Clear first or not? That's chemically anything that burns is reacting with oxygen in the air.
Okay.
Anything. So hydrogen reacting with oxygen. If you do it in open space, it is an explosion. It is a rather big explosion, enough to throw you off or burn everything up, or burn everything. And that is what happened with the hydrogen balloon. Sorry, this is old history. Back then, they fly with hydrogen balloons. Back then, when plane is still not very advanced, your Boeing 747 is a big hydrogen balloon. Unfortunately, it is not hot air because hot air don't burn. It is a hydrogen balloon, a balloon filled with hydrogen, a super big hydrogen balloon. That's your Boeing 747, super slow. The end of that technology, hydrogen balloon, is also a dead end technology. It does not develop. You know how it ends?
Hydrogen balloon. What else can you do with nothing?
No. They thought hydrogen balloon is the future at any point. Electric car is the future. I don't know, man. I don't know about that. But hydrogen balloon, they thought was the future, right? You can basically float in the city slowly, with hydrogen balloon. How did that technology end? By the hydrogen balloon exploding and killing everybody. Right? Hydrogen react with oxygen, boom, finish. Which is what's happening.
It just become water.
Yeah, the water is not the danger.
The heat.
Look, sodium. Yeah, sodium react with water. Water is not dangerous. Sodium is not particularly dangerous. The reaction produces a lot of heat and it explodes. That's dangerous. Needless to say, if you're up there and the hydrogen balloon explode, either you cannot explode or you just drop, which is both not so nice for us. And that's how the technology ends. So hydrogen has a lot of problem. That's it. That's it. Hydrogen has a problem. Now this fuel cell is trying to not produce heat. He's trying to produce electricity out of hydrogen and oxygen. So the reaction here is more controlled, less explosive. You don't want an explosive battery for obvious reasons. Okay, I'm telling you this at the start so that the reaction don't look confusing. By right, if you see this reaction, hydrogen to oxygen, people are supposed to think that it's an explosion because that's what normally happens. Right? You know the test for hydrogen? How do you test for hydrogen?
A lighter steam pops.
Yeah. Do you know what that pop means?
No.
It's a tiny explosion.
Okay.
It's a tiny amount of hydrogen. You test it using flame. This is my biggest problem with your syllabus. You're not supposed to test hydrogen with flame. Crazy. But then again, in lab, you don't accidentally produce all hydrogen. Just imagine one guy don't know anything. The lab apparatus accidentally produced many hydrogen. He remember the syllabus. Oh, I'm supposed to test hydrogen with flame. It lights out the flame, boom. It's not a pop, It's a billion pop lah. It's an explosion, no? At this point, I'm still very concerned why in lab you test hydrogen with oxygen. Small amount, okay lah. Big amount, what will happen, right? Telling you for you, not for the syllabus, right? Telling you for you. Hey, I'm telling you this so that there's a lot of context here, right? And now we're supposed to figure out the half reaction because the full reaction is not the story is in the half reaction. Okay? Right, so since the anode and cathode is not reacting, the hydrogen is reacting. Well, I think hydrogen is very easy to figure out what happened. So H2 will just become, can you make a guess? What does it become, the half reaction?
2H plus 2E.
2H plus 2 electron, correct? That's it lah.
Yeah.
Which is why the electron flow is exit. Which is why back then, magnesium react. Magnesium is Mg2 plus 2E. That's
H2
why.
will just do this. Like H2 will just react like that for no reason.
No, the story is more complicated. H2 will not just do this. It will not. You have to kickstart it. They never tell you the kickstart out of the syllabus. So for your syllabus, it will happen. No, H2 don't normally do this. There is a kickstart happening. Not in the syllabus. Good question from you lah. Good question. Okay. You're right to say that H2 does not do this normally. Nor will the oxygen reaction happen normally also, right? Okay, so anyway, I start with the hydrogen because that's the easiest one to start with, I feel. Same thing with Mg. I start with Mg. Mg and Al. Mg react lah, so electron will flow lah. I'm happy low. H2 will react low. Electron will flow low. Something like that. Only works in a fuel cell. Now, what will happen to the oxygen reaction? The total reverse of the reaction in electrolysis, which is the more complicated one. Kind of-ish. Kind of. Never mind. Look. The drawing goes like this. Hydrogen, right? Hydrogen. Yeah. Electron go up. By the way, this small thing is electron. I don't know why they don't label, okay? I think these small things are supposed to be electrons. I think that.
Yeah, they're not bubbles now.
Yeah, they are not bubbles. There isn't supposed to be bubbles in a real battery. Bubbles cause a lot of problem. Just that you don't learn this in syllabus. Bubbles are a lot of problem with battery, right? So these are, I think, supposed to be electron going up and then electron going in. So right now, we should be thinking something like this. Oh, wait a minute. So this must be oxygen receiving electron. Must be lah. Correct or not? Must be lah. Right? Which unfortunately does not end as easily as this. This is wrong. This is wrong. This doesn't happen to oxygen. Long story short, they never tell you in syllabus. You will learn them if you decide to take chemistry in JC1. Yeah, but at this point in O level, I'll just say, no, it doesn't happen this way that easily. Unfortunately not, right? So a little bit complicated. If you want to receive electron, first thing first, the only option you have is to become OH minus. It cannot become O2 minus directly. Cannot. I don't tell you exactly why, but like that. To do that,
OH minus, then the H from where?
See, a very good question from you. You are a reasonable chemistry student. You are reasonable, right? From H2O, from water, which I now balance this. I will now balance this. This is 2, I think. It will be 2. Yeah, okay. This will be 2. This will be 4, I believe. And this will now be 4. That will be the reaction. Reversed.
Yeah.
In reverse. The electrolysis one, the arrow is like this. Electrolysis. So no surprises to anybody in battery, it's reverse. No surprises to anybody. It shouldn't be a surprise. Look at the hydrogen reaction. The hydrogen reaction, same thing, The hydrogen reaction, the electrolysis flow is supposed to be the other way. Correct or not?
Yeah.
And then battery is the reverse. No surprises, electrolysis and battery is the total reverse of each other. No surprises at all. You're right. So if you just learn it that way, oh, my oxygen reaction will be the reverse of electrolysis, then you don't have to memorize two things, so just one thing like
I
that.
understand
You
that,
know?
yeah, the reverse stuff. Then both are reverse. Yeah.
Both are reverse, so it totally makes sense. Totally makes sense, right? Then what happened to the hydroxy ion? I don't think your teacher explained fully, but what he's saying is that the hydroxy ion will move to the hydrogen side for whatever reason, not explained here, I don't think so, and then combine with the H plus to become water. That is your
But it says
water.
that that's it says that the hydroxide ions are the electrolyte.
No, it is inside an electrolyte, which is usually a simple electrolyte like Na, something which is not corrosive. The point is, it is an electrolyte.
So it doesn't matter what electrolyte it is.
For some reason, no, it doesn't. It doesn't. It does not. So it's very weird, right? In a normal battery, one of the metal partake, the electrolyte also partake. In a fuel cell, it is such a very, a very clean battery. The hydrogen and oxygen react, the electrolyte not partaking, so we don't need to replenish. The anode and cathode not partaking, also no need to replenish. Just replenish the hydrogen and oxygen. So clean, except that the problem is the hydrogen, except that. There's always a problem, right? They originally designed this so that they don't have to change the battery. Battery gone 1 month. They originally designed this so that the battery can be, so to speak, recharged very easily with hydrogen. Turns out that they're just shifting the problem from electrolyte and anode cathode to the hydrogen side. It's just a shifting of the doesn't solve the problem. That's the background story. Now, I don't know why the drawing here is a little bit incomplete. Like they never tell you the bubbles are actually electron, very misleading. They never tell you the electrolyte. They just tell that the electron does not partake, which is correct. And they also don't tell you why the hydroxide ion migrate to the left. But at least they tell you that the H plus and no, actually they don't even tell you that the hydrogen produce H plus. Okay, so I tell you that H plus and then it combines with OH minus and it becomes water exiting. That's finished. Unless you have a great need to understand fuel cell, in general, I'm not very motivated to teach beyond this because it feels like a dead end technology. As long as you understand this, enough for you.
Yeah, I understand this. So like that's it lah.
Until you test it out in an exam question, just test it out. Then you will know whether you understand. Yeah.
But is there any exam question you have on this?
There's once that there's a major, because in chemistry paper 2 there's the physics paper 2 there's always the the 2 or 3 questions at the end which is very long, right? Remember that? Do you know already that paper 2 like chemistry paper?
The FAQ.
What's the
FAQ? The free response question. Not free response question. The I think it's called like database.
The point is you have to read a lot. First thing first, you have to read a lot, and then you have to answer quite a number of questions. Like it's like reading comprehension in English, like long reading and a series of questions, something like that. Okay. The point is you have encountered them. You know that they exist.
A lot. Yeah, in every single paper now.
Correct. So 80 marks, 50 short, 30 long. 30 long divided into usually 3 questions. That's how they divide them. Same thing in chemistry. So once in one of the O level, there is a long question on fuel cell. Why is that so? Because the long question will always rotate one. They always rotate one, and they don't avoid any topic. If so to speak is the turn of this topic, then they will make a long question out of it. And since a battery is supposed to be a very short concept, they cannot use a simple battery.
So they
a fuel cell, which is a slightly more complicated thing, so they can make it longer. And then they can give you more information to read. Because what they want is that, let me give you this thing which is outside the syllabus. Let me give you something more than syllabus by giving you all the reading required. And then I'll give you questions which combines the new thing that you read and the thing that you learn from your syllabus. That's the intention. No? And that happens once on fuel cell, which leads me to think that it will never happen again. Because that is the purpose of the question. The purpose of the question is to give you something new, which means it's very unlikely for the fuel cell to happen in the long part. So I've seen, I think, 3 O-levels beside that, which the fuel cell happens in the short part or sometimes the MCQ. So it's a very short question compared to the long. That's it. It doesn't happen all the time in every O-level, but it happens from time to time. I wouldn't be too worried about it. If your strategy is predicting which topic is going to happen in the long question, and you predict fuel cell,
but most of the time they will give you enough information that you don't need to care.
Precisely. You already have the right attitude and the right understanding. The reading matters. That's why you're saying that it's reading comprehension. The reading and the comprehension matters.
No, it's never been a problem. It's always the other question.
Correct. Then fair enough, if fuel cell happens in the short, the 50 marks part or the MCQ, then you do require the syllabus understanding, which I just explained to you, like that only. Right? So time to test your understanding in the exam level question, which will probably encounter from time to time. For fuel cell. Maybe more likely to be the simple battery one.
So I opened the thing last time.
I mean, if you want to, but I would prefer that you ask other concept. I would prefer if you have a conceptual problem. No need to practice.
I don't think I have any more.
Right. Just to confirm, first, physics also no problem.
Physics.
I mean, if you have to look for it, then probably not.
I think we haven't been missing a lot of classes because this 3 weeks exam period.
I mean, at this point, we are supposed to do exam questions anyway. So fair enough. You open the drive.
I have a physics question. I remember.
Oh, sure. If you don't mind, if you want, just ask them.
I don't know. Okay, so I see this circuit twice already, and I got it wrong both times. Like
okay, please ask.
They give something like this. Like when it's like when there's a diamond, right? And I'll redraw myself.
You have to draw the resistance there. You have to draw the resistance, okay? Or maybe this is a diode question.
I don't remember the resistance. Okay, I think I think I remember. So
you have to remember the location.
Like there's one here, one here,
one
here. Then there's a line here, right? Then this is 10.
Yeah, the problem is always the middle. Yeah, the problem is always the middle.
Yeah, but I don't know how it works.
I will explain it. Now, I'll put this as 10 first. Is it okay? Easier, 10. Okay, 10, easier. Okay, then we'll talk about the 100 once you get it. Okay. Now, this wire, if you remember correctly, has no resistance at all. Correct? Okay, when there is a wire which has no resistance, it is extremely easy to deal with, at least in O-level. Let me give you an example. Look at this other part of the wire. This one, I highlight in blue. This wire also has no resistance, correct?
Yeah.
Such wire can be lengthened or shortened to whatever you want. Let me repeat this. When a wire has no resistance, you can shorten it or lengthen it however you want it. The concept stays the same. Let me give you an example. The blue part, I can make it like this one.
Yeah, can. It won't matter.
Will it change anything?
No.
Okay, now that's lengthening. Now I'm going to shorten it. Okay, I'm going to shorten it. So I'm going to shorten it to like this. Sad. Will it change anything?
No.
Okay, now test you more. Now the visual become complicated. Just now still easy. Now I'm going to put the battery. I'm doing something extreme, okay? I'm putting the battery here. Okay, did you correct? Did you? Oh yeah, it's
you
okay.
flip
It's
the
a long one.
polarity.
Okay.
Yeah.
No, I didn't. The long one is still the nearest one here, right?
Correct.
So that's why I did. That's why I did, right? So I did. So I'm going to do that. Okay. So what I did was I put the battery now like that. So I'm making it very short, the blue wire, correct? Very short, but I have to lengthen the other wire, which again is not a problem because there's no resistance. So far so good. Nobody draw this lah in exam lah. Nobody should draw this. It's very confusing. But my point is, I am confused. I'm trying to confuse you. Are you confused?
No.
Because any wire which has no resistance can be lengthened or shortened without changing anything. Now, therefore, you shouldn't do this. Therefore, you should actually shift the battery here because you can do that, right? You shouldn't draw the battery because it is confusing. Okay? It doesn't matter to the circuit. It matters to us human beings. So, I mean, again, it doesn't matter to physics, but it matters to us. So we should not draw it confusingly. We should shift the battery. So far, so good. That's the concept with a wire which has no resistance, so to speak. Okay. Now, let's talk about the wire in the middle. I can lengthen it, I can shorten it, I can change shape. Just don't add any resistance. Now, if I lengthen it, just imagine, Orowa, will it help you? It doesn't help you though, right? It doesn't help you. It is still confusing, right? Now, watch me shortening it extremely. Watch me forward. Watch me shortening it extremely. Yeah? Watch me, yeah? In my effort to shorten that wire, I make the wire into, well, almost nothing. I shorten it like that. Okay? Can you imagine that? Now, is this still confusing?
No.
Are you sure you can do this? Because if you can do this, problem solved already.
Yeah, it's not confusing.
Okay, then tell me how are you supposed to handle this? Tell me, series parallel.
It's just as is two parallel circuits in series.
Tell me which of the two parallel is parallel. Just tell me.
I can just redraw. Just redraw this.
Oh no, just laser point to me. Who's the parallel one?
These two parallel together, then these two parallel together, then this.
Very good. Yeah, that's it. That's it. Because when people is confused, I usually draw the other modification, which is now I will do this.
Wait, but why can't you just? Wait, but can you add wires?
No, you cannot. Do not add wires. But I wasn't adding wires. I was just lengthening or shortening it.
But why
cannot.
Why is that the same as? Because that is the same as this one, no? They're the same, right?
Yes, it is correct. It is correct. Yes. But I'm not adding wire or making wire disappear. I'm lengthening it or shortening. Let me explain. Now I am now adding.
I get what you're saying.
If I add wire like this is going to be very weird, right? If I add this,
but we
this guy disappear entirely.
Yeah, because the current will go through here.
Correct.
Because it's lower resistance.
Correct. So basically, your teacher usually teach you like this in a slightly different way than me. Your teacher teach you if there is this is called a short circuit wire, by the way. A short circuit wire is a wire without resistance. It's a very simple one, okay? When you have a short circuit wire, you just pinch the two ends, something like that. And then the end that you pinch will disappear. But in this case, he will disappear, not the wire. In this case, but that is not a very good way of teaching. I feel like it can still become confusing, right? So I don't teach that. Now, what I'm doing is really just lengthening or shortening. If you can see that, then there is no problem. There should be no problem with that concept. If you're happy, that can be the end of our discussion. That's it.
So then, how do you okay? Let's say you bring it back to this, right? With the fourth.
Yeah.
With the line through. Because the current is like that, right? I'll change color. The current for is flowing this way, right? Then what about in the middle? It's this way.
Yeah. So if you want to know what's the middle current, again, to be fair, the wire is still there, right? So even though we change the drawing, physically the wire is still there. So our concept can change to suit us, to make ourselves less confused. But the reality is the wire is still there. Now, let me tell you the answer. The answer is that people know, or people usually learn how to tell the wire current direction in university, not even in JC. I learned how to tell the direction in university. I think, semester one engineering. It's not a difficult thing to do. It is not. It's just that, they also learned that in Polytechnic second year, I think. I think they also learned that in Polytechnic second year. If you take engineering, it's not a terribly difficult concept. It's just that they don't teach you in the syllabus. Never mind the A-level syllabus. They don't even tell you. They don't even tell you there. But the Polytechnic syllabus, I think, so you don't have to worry, is what I'm trying to say. Unless you really want to know, I'll explain to you. No problem.
No, is it important?
Not for O level and not for A level, just for poly.
Yeah, but I'm not okay.
So what you need to know is that you can, pinch it or lengthen it. That you need to know. So you can modify so that you finally understand the drawing. You can do that. You should do that. As for the physical side of things, I guess you don't have to worry about that. Because there are reasons why people constructed it. There are reasons. They just put a wire there. Why don't you just draw it this way, for goodness sake? Why don't you draw it this way? Because there are advantages in doing this. There are. But they don't tell that.
Yeah, I think I want no more misconception. Okay, that's really okay.
Okay. At this level, we are either supposed to go forward, which we don't need too much yet. We're still waiting for NH, or we go to exam level questions, which we can do right now. Should we do that?
Yeah. Okay.
Okay. So are we trying to look for the fuel cell question? I suggest that we look for both the fuel cell and the basic battery question. I suggest, yeah.
Yeah.
And as yes, we do that in the MCQ side of things first. Much easier to look for. Let's go to the MCQ side. Okay? Yeah, MCQ first. You should realize by now the MCQ, the order of the question is by topic one, like very tidy, chemistry, biology, and physics, all very tidy by topic one. Do you know that? It's not like mixed up like the paper two. It's not. They really order things one. Meaning to say, the electrolysis question will always start around question 31 or 32, maybe 33, and then the battery question usually follow after that. So just zoom into MCQ around question 30 something, you will see electrolysis and battery. I suggest that whatever question captures you, we discuss them. Okay? Okay?
Yeah, do you need me to
go to MCQ? I think that will be better. I'll stop my screen.
Yeah, okay.
I'm curious whether you can spot and differentiate the electrolysis and the battery question. If you cannot, that is the start of the problem. That is the problem.
Oh, share screen. Cannot.
Oh, you can. Yeah. So go to question 30 and then start looking from there. Yeah. So slowly look low. So not 30 lah. So just electrolysis lah, but there's no drawing there. If you want to talk about that, feel free. It's a electrolysis, right? Okay. Now question 36, they also say it's electrolysis, right? Now 37 also say electrolysis. Are you sure? Look at 38 for a while, just to confirm. No, it is not. Yeah, it is not. There is no battery question here. But this is normal. They like. Oh no! Don't look at SA1. Of course, SA1 they might not have covered battery. Look at SA2. Look at SA2. Look at SA2 below. And don't look for the combined one. I mean, whichever year doesn't matter. Whichever year, just don't look at SA1. Look at SA2. Yeah. So MCQ lah. So again, go to question 30 and start looking there. Too far already. You're already at the next paper. Too far. Go up again. Yeah. Go. Just it's very close. Right? Very close. Oh, what's going on? Just good. Yeah, just good. Just good. Yeah, yeah. Go almost. See, almost 30 already. Okay, there you go. Not yet. Not yet. Not yet.
No,
Yet.
it's not really.
Yeah, shouldn't matter. Sorry. Okay. Enthalpy, so not electrolysis,
sorry.
but still not. Fuel cell. There you go. Oh, it is a fuel cell. Okay, sure thing. There you go. Okay, so copy and paste, put it in the Jamboard.
Which one is the cathode?
Which therefore you should just draw lah. Should just draw, or you should.
The one on the left is the where I can't. The one on the left is the.
I'm gonna copy paste. No, you cannot. You cannot measure. You cannot memorize left and right. That's the worst thing.
No, but the one on the left is hydrogen. Then hydrogen. Oh wait, hydrogen. Wait, no, hydrogen goes to the reduction. That means on the left is cathode.
Hydrogen goes to reduction.
Wait, no,
Are
hydrogen
you
is
sure?
Yes. It's H2 to H plus. H2 to H plus.
Correct. So B must be wrong lah, but don't know whether A is wrong. Don't know whether A is correct lah. Don't know lah. Okay, is that what you call anode? Is the oxidation happening at the anode?
Yes.
So some teacher will teach red cat lah, right? Reduction, red cat, anox, right? So reduction happens at cathode all the time, fuel cell and electrolysis. Then anox, anode, oxide. So A is currently correct. So C loses electron to form H plus ions at the anode. Wait a minute, that does sound, oh my goodness, A is wrong. A is wrong, C is correct. Because A say hydrogen ion are oxidized. That's wrong.
Hydrogen gas.
Yes, correct. So A is wrong. C is correct. Which that means you understand the basics of fuel cell. You're at least referring to the right thing. Just reading perfect. Okay, exam level question, right? Okay, if you have no question, let's see more questions. Well, already OCHEM, is it? When it's OCHEM, then no more lah. Then no more. Okay, let's check the next MCQ. Question 30. Oh, this is the same thing. This is the answer key, isn't it? It's the same thing.
Oh yeah, this is the same thing. Oh yeah.
Oh, there you go. There's a voltmeter. There's a voltmeter. Yeah, 31, voltmeter. 31.
Oh.
Why do I emphasize voltmeter? Because if I see this and I see a voltmeter, I know immediately that this is
it's a battery.
Correct, not electrolysis. So copy and paste. Oh, this is something that they may or may not teach you. Again, simple stuff, but it's just that they may or may not teach you.
This setup will produce the greatest reading. No, it does this. Oh.
You have to be clear first, John T. Is this like the advanced fuel cell or is like the basic battery?
Basic battery.
Correct. It's just two metal, right? It's two metal. Uh-oh. Uh-oh.
The glucose? No.
Uh-oh. Hey, why are you going in and out? No, it's fine. No. Why do you cancel B, if I may know?
Because I only saw glucose, but it's solution. That means it can conduct electricity.
Yeah. Solution still can lah. The distilled water is the problem. So you know distilled water almost cannot conduct lah because almost no ion. Good.
Yeah, that means it's D law.
Why do you think that? Why?
I see think it's because magnesium to lead is a bigger jump than
zinc and copper.
Yeah, because magnesium very reactive, right?
I mean, yeah, at least it reacts with water, cold water, like so. It is kind of reactive, lah. It is kind of PB and CU. I mean, they are not very.
But how
they are not very far.
Bigger jump or not? Because one step down doesn't necessarily
mean a bigger or smaller jump. Correct.
Doesn't necessarily mean that.
Correct. No, you are absolutely right. One step doesn't mean equal. The one step here is not equal to the one step there. Further worse, it's even worse than that. Your reactivity series is not complete. So the one step can actually be 2 or 3 steps, even worse than that. Okay, now you are thinking about the right thing. Okay, I am happy talking to you, lah. Now here's the long story kind of short lah. So the long story kind of short is that you have to make some guesses here. You do because you don't have a complete reactivity series. In JC, they give you the value of the jump because you can test them actually. So it's by experiment. There's no theoretical understanding of it. People just test lah how many volts. Then they can tell how big the jump is. So in JC they just use table, right? So nothing complicated actually. But in O level they don't give you the table. They don't give you the value. They give you an incomplete reactivity series. So I'll just tell you the principle in the reactive series. They tell you EB, H, and Cu are almost too close to each other. They are very close to each other. That is, I think, the only thing you need to. EB, Cu, and H are very close to each other, so their jump is small within each other. Yeah, D is a better bet than A, better bet. Because I think A is the second one, definitely C is not, because Cu and BB, although it is a jump, it's a very small jump. So we don't care about C. But this is a little bit of a guess from our side. You are correct. You are correct. Absolutely correct. Yep. So we got that. Okay, let's move on to the next paper. That means you have to go through paper 2, right? Okay, wait, it's another paper 1. That's so weird. Okay, let's go to question 30 again.
The same paper.
Doesn't look like it. Doesn't look. Oh, it is. Oh, it is. What's going on here? That's so weird. What is so weird?
It's the same paper.
Yeah. And we are finding the answer key, which is the answer key for the paper 2, which is extremely weird, right? Okay, so now this is another paper. You ignore the answers, yeah? You ignore the answers. They might be right, they might be wrong. Who cares? Right. Now, question 30. Okay, and so, oh, that looks like a very similar question, but it is not. Okay, question 30 is electrolysis. So unless you want to talk about electrolysis, then you don't have to. Now, the formation of liquid water from hydrogen and oxygen doesn't sound like it is an electrolysis or cell question, but it is the electrolysis or cell question, which the reaction is totally different from what they teach you. Oh my goodness. Oh goodness me. Oh my goodness.
They not teach, huh?
Because endo is partly logic and partly memorization. Now let's look at let's ignore the fact that the reaction is different. Yeah? Let's just ignore the fact. Let's just take it as what they give us. Look at stage 3. Stage 3 is actually very simple to use logic one. You should know immediately whether the stage 3 one is endo or exo just by using logic, no memorization.
Guys, exo, because
how do you know?
It loses heat, so outside must gain heat.
Let me test your statement. From water vapor to water liquid, right?
Yeah.
From water vapor to water vapor, you're supposed to lose heat, not gain heat. Are you sure that's correct?
Huh?
I'm testing your thinking here. Right? I'm giving you a pressure.
Yeah,
are you sure? Are you sure when you add heat to vapor, you don't make it liquid? You have to take heat away from vapor to make it liquid?
Yes.
Are you sure? Okay, good. Because you're correct. So what do you call that? Exo or endo?
It's exo because it loses heat, so outside will gain heat.
Right. So obviously C and D gone already. Okay, obviously, right? Now I think the question, the stage 1 reaction is the hardest or the least familiar one. Meaning, look at stage 2. The reaction there, oh goodness me, these reactions are not.
Just now you.
Oh goodness me, the reaction. This reaction you're not supposed to. Oh my goodness, what is happening here? They are not supposed to show this reaction. This reaction doesn't make sense to O-level student. It does not make sense at all. Oh,
but you know it's exothermic one, yeah?
because stage 2 reaction looks similar to hydrogen gas combined with oxygen gas, but it's not that, but it looks like it. So when you see hydrogen gas combined with oxygen gas, the key is the oxygen gas. Anything combined with oxygen gas is usually burning, which is exothermic.
Yeah, because just now you say already, right?
Yeah, correct. But the problem is the stage 2 reaction is not a hydrogen gas and it's not an oxygen gas. I think this question is unfair to you. You never learn this. This is something you learn in JC, and even then, it doesn't make a lot of sense later. I suggest that you ignore these reactions. I'm sorry. I suggest that you do. We'll talk about exo-endo question in another one because the reaction shouldn't make sense to you. And we have no battery questions. Really, we don't even have electrolysis question. Really?
No, there was an electrolysis question on top. You want to? I kind of want to try it because it's
Okay, let's see. You want to try? I mean, it's not a very difficult one. I think the top one also, no. So let me see the question 29. Can you see question 29? Sorry. It is also electrolysis. Yes. 29 and 30. You can try if you want to.
But this one need calculation.
I'm sorry, you're saying?
This one need calculation.
Yeah, it's weird, right? Electrolysis question that requires calculation, and yet that's the most common electrolysis question.
2.0 gram of calcium metal. Calcium.
14.
Yeah, so it's 0.05 more. Okay. Video. Bro, what is electrolyzed?
I'm sorry, what is the what?
What is electrolyzed?
Sorry, just to confirm, where is that word? Where is that word? Where is electrolytes?
Question 30.
Electrolytes, right? Electrolyte is just a verb, no? Meaning an aqueous solution is being electrolyzed, meaning undergoing electrolysis. It's just a verb. Does that make sense?
So it is the electrolyte.
Because the solution must be the electrolyte. It cannot be anode and cathode. That means there is an anode, there's a cathode. It's just that the whole thing is there. It's just that for some reason he chose to focus on the aqueous solution because no, that's actually very weird. Why would he focus on the aqueous solution? Because the whole package is there anyway. So that's a little bit weird, lah.
The graph below is obtained.
I mean, the mass of cathode increases, lah. I mean, that's not surprising, right? You at least learn that could happen, correct?
Yeah.
So he's asking you which combination of cathode, anode, and solution T. Solution T is the electrolyte, right? Which combination will not increase the mass of the cathode? Correct? That's the question.
The first one.
The first one. Then let me ask you, I mean, the C is obviously correct, correct? The C is obviously will increase. That's what you learned, no?
Yeah.
Correct? Then why is B and C also correct? Can you answer that question?
D is the same as C.
Except that the copper nitrate solution will run out after a while.
Yeah, but
Except,
yeah.
So at least B is not very correct. It's just that A is worse. A will not produce anything. A will produce gas
got
lah.
no metal to form.
Correct. So it'll just produce gas, no? It'll just produce gas lah. So fair enough lah. A is worse than B. Why is D correct?
Because is the one I asked just now is the purifying, except like the silver of form here.
Fair enough. So you're purifying silver, which is usually an unnecessary thing to do. You can just burn silver to make it pure, but copper cannot. That's why you never purify silver, because you don't need to undergo electrolysis. It's a costly process. It's an expensive process. But yes, D will give you increased mass of metal. Right. So no more electrolysis and battery question. Of course, you can go to the paper 2, but we'll go through maybe one more MCQ. We'll go through one more MCQ before we jump to the paper 2. Wait, stop. Obviously, wait. This is obviously what?
This is both, because there's one battery, there's the one without.
No, this is only electrolysis. Wrong, not because they tell you it's electrolysis, not because, but the wire connecting both is that just means that there are two electrolysis package connected to each other. It's not true that the middle one is a battery. That's not true at all. If this is connected to a battery, it does not become a battery. The reaction here will be driven by the battery. So it will not be a cell question. It will not be. So the Q to R connection is just the connection of two electrolysis things together. If you've never seen this before, then the news is that this is a standard exam question. It's very weird that in your note, they kind of teach you only one, and then suddenly in the exam, they show up with 2, 3, or 4 packages connected to each other.
I have to assume that electron flow is this way.
According to the battery one, which you didn't assume. You are wrong. You are wrong in your assumption. Why do you start with the wire without the battery? You should start with the wire with the battery.
Oh, so it's like that.
Like that, yeah. So that part is easy like that. And then you suddenly realize that there are just two electrolysis things, because the electron flow is still, once you work out the electron flow, you can cut off both sides and you just think separately, no problem.
Yeah, of course you can.
Yeah, because the electron flow is established.
The two water is different.
Different, no? Yeah. Different and separate. Different and separate. You have to now think about cell 1 and cell 2. They're called cell, I know, but they are not batteries, okay? They're called cell, but they're not batteries. So cell 1 has its own reactions. Cell 2 is its own reaction. Once you establish the electron flow, easy peasy lah. Agree with that, okay.
What oxygen or nitrate?
Yeah, but the S is receiving electron. You shouldn't be considering nitrate. How can nitrate, a negative ion, accept electron, right? I should be copper lah. Yeah, is it not?
Oh, that's confusing because we don't see nitrate.
Again, the electron flow is the most important thing lah. So make use of it lah. You should draw the other one. Yeah. It's just that I feel that you're drawing the electron flow just only half. You should just draw all lah, right?
Why there is a change in the pH of cell 2?
Yeah, fair enough. A very fair question. Must always have something to do with half reactions. Always have something to do. You don't think before you figure out the reaction. If you try to think without figuring out the reaction, waste of time.
This one is the OH minus, right?
Where? In the S or in the R? How come you're doing two reactions? Okay, in the R. So are you sure it's OH minus? Are you sure? Just checking. I mean, to be fair, there is no other option, right?
Yes, I'm quite sure.
To be fair. Yeah, there's only OH minus changing to oxygen, right? Something like that. The reaction you get.
So this one is OH minus or
Changing to 4, yeah, blah, blah, blah. Okay. Now, the point is, why does this change the pH? Are we on to the right?
It becomes more acidic.
Yeah, because you consume the OH minus.
You lose OH minus.
Right, correct. Okay. That means then see, you're thinking based on reaction, your answer is usually correct one. I mean, it's chemistry, my reaction is the most important thing. I know, something like that. So. It's like, no need to write, no need to write, waste of time. So unless you want to form the sentences right now, you don't need to. It's okay. Better type anyway. No need, you already know the answer. You already know the answer.
Oh.
Yeah, no need to, no need to write with mouse.
But the phrasing is correct, right? That's right. As OH minus iodine lost in cell 2. So
yeah, I will actually write the reaction, by the way. I will actually write the reaction. In R, at R, write down this there, and then OH minus is being consumed. Therefore, the pH will be acidic. The explanation done. The reaction is the explanation. It's a very good thing in chemistry.
Yeah.
Like in physics, the formula is the explanation. In chemistry, the reaction is the explanation. Like they see the reaction, they know that you know, they're very happy to see. They don't think like this. Hey, what is this guy? I asked you to write in English, you write in reaction. They don't think like that one. I mean, they're not English teacher, you know, they're chemistry teacher. They see a reaction, oh, the reaction is correct. This guy know what he's talking about. Something like that. This is OChem, right? You'll be seeing this. This is a redox probably. This is OChem again. You will see a lot of OChem. Another OChem.
OChem is so big.
For the long part of the question, you will see very frequently 2 OChem questions. They really like to react. Is this, I mean, this looks more like a physics question, right?
What is this?
I mean, to be fair, this must be either electrolysis or battery, right? It must be, must be. So is this electrolysis or battery? They don't say. Which one?
This is electrolysis.
Why?
Because there's a battery there already.
Fair. The light bulb is a bit confusing, to be fair, right? The light bulb is confusing, right? So, but okay, let's assume that this is electrolysis. So, the light bulb lights up in only one of the circuit, and they don't even tell you which one. That's very annoying. Oh my goodness, this is a physics question. This is a physics
Why I
question.
don't understand it. How is answer D?
Right. So again, for some reason they tell you all this, and then they ask you to identify X.
Okay,
so it turns out.
C is out, right? C is out.
Because polyethylene will never conduct electricity.
Yeah.
Is that your thinking or not? Okay.
Yeah.
And B should be also out, right?
B is out.
Oh wait, aqueous. I'm sorry. Aqueous.
No, but sugar cannot conduct electricity in solid state.
I know.
Oh, no, that is correct.
No, I know, but I mean it's weak lah. To be fair, it's extremely weak low. So maybe there's a better answer, right? MCQ can do that one. So sugar is technically correct, but practically very weak.
No, but my answer was lead chloride.
And you are. Let me think for a while. Wait a minute, lead chloride is. Let me think for a while. No, lead chloride is wrong. So, oh yeah, lead chloride is wrong. Sodium oxide is right. Yeah, because lead chloride it's solid. Obviously, doesn't conduct electricity. Obviously, that same thing is sodium oxide. So both side is correct in the left circuit. In the right circuit, you're assuming that lead chloride will form a nice ionic aqueous solution. That's why you think A is correct. And you might think that the sodium oxide will not do that at all.
What do you mean? I don't understand.
Again, you're saying that A is correct, D is wrong. I think the other way. I agree with the answer D. I think A is wrong, D is correct. Now let's be clear first. In the solid side, both A and D will cause it to not conduct electricity. So the left circuit, A and D will be correct. Clear first?
Mhm.
But in the right side, you think that lead chloride will become A plus ions. That's what you think, right? Why are you switching? Are you okay? Can you hear me, Jonty?
Yes, sir. Wait, but what? You
Paste it.
Hmm?
Oh, goodness me, that's very good. Never mind. I just write down. No, sorry. Let me just write. Let's close this quickly. Okay, so the issue is lead oxide, PbCl2, or sodium oxide, right? Okay. Right?
Yeah.
And then we have a simple electrolysis cell. Just focus on the electrolysis cell, which is supposed to be aqueous, right? There you go.
Yes.
Right? And then the circuit doesn't matter. The circuit doesn't matter. Now you are assuming, therefore, that PbCl2 becomes Pb2 plus NCl 2Cl minus. That's your assumption, correct? And therefore, this conducts electricity,
Yes.
correct? And you assume that sodium oxide cannot become. My drawing pad battery just died. So you assuming that sodium oxide cannot become Na plus. Na plus, and in this case, O2 minus, something like that. It cannot become, and therefore this is wrong and this is right. That's your thinking, correct?
No, my thinking was that both are correct.
Oh, fair enough. So you think that both are correct. Now, first, let me explain why sodium oxide is correct, just to confirm. Sodium oxide is correct because it will react with water first to form sodium hydroxide. So then it will become Na plus NOH minus, which obviously will conduct electricity. So there's that reaction. And you learn this, and you learn this in the acid-base oxide chapter. Okay? So sodium oxide is correct.
You learn it in the course.
And fair enough, you learn this metal. Now, you learn in the chapter before metal that lead chloride will not do this because it is a precipitate. It will not dissolve. It is insoluble.
Oh, it's insoluble.
And that's why it will not conduct electricity. That's why. This question combines knowledges from, obviously, previous two other chapters, plus physics somewhere. It's a tricky question.
Wait, so
I think it's
lead chloride does not exist.
You want the short answer or the long answer?
Short answer. Because long answer
No,
is
it does
chemistry.
not. No.
Chemistry is about long
No, it does not. No, it does not exist in O level. In O level, you assume that it doesn't exist. So sorry, it's wrong. Something like that. The electrolysis question opens up a lot of possibility for tricky question, meaning tricky question, they combine many topics. In this case, 3 topics, crazy plus physics somewhere. And they do it in a way that is misleading. This question is crazy in terms of how it can mislead people. Electrolysis topic is their favorite topic to do this because electrolysis encompasses super redox, mole, acid base, solubility, metal. They combine everything before. That's why electrolysis is the last chapter before O2. That's why. So that's why electrolysis questions are always very tricky, and I like to do that with students just to hone their other topic. It's not for electrolysis. That's the main use of electrolysis question. Now, battery does not do that. The battery question is very simple one. The electrolysis question is the tricky one. Anyway, to tell you that means if we go to exam and we try to practice this kind of question, it may make you grow, which, I mean, for example, this question, it did make you grow. Okay. All right, Janti. Good job for today. I'll see you next Monday.
Okay. Thank you. Bye-bye.
All right. Okay. Bye-bye.